Clinker Factor, the cement industry podcast.
Welcome to the Clinker Factor, a podcast from WCA, which looks at the cement industry's response to climate change around the world and other topics of interest. I'm Ian Riley, CEO of WCA and your host on the Clinker Factor. The cement industry has been working on decarbonisation for many years using three traditional levers: energy efficiency, fuel switching, and reducing the clinker factor. And today I'm talking to David Boyd, who's the Chief Commercial Officer of Carbon Re. And Carbon Re deploy AI and machine learning to improve cement kiln combustion efficiency, and are also a WCA member. Carbon Re have just published a white paper titled 3 Technologies to Reduce Climate Change, about which we'll discuss more later. So David, welcome. Perhaps I could get you to start by introducing yourself and how you got involved in the cement industry.
Thank you. Yes, so good to see you, Ian. My background is as an engineer. So as a kid, I still remember growing up in Derbyshire and walking around, just trying to understand why different materials were used for different things. You know, lampposts, roads, why did we use the materials we did? I ended up studying mechanical engineering. I actually did some civil engineering as well, block work on a Czech Republic airport when it was being built for a civil engineering firm. Found my way into the steel industry after graduation. And worked in the UK and in Europe on rail production, on the kind of downstream end of steel. My career then, because through engineering, I got a lot involved in mergers and acquisitions, actually focused on mergers and acquisitions for 10, 15 years, as well as digitization, data-driven software development, a variety of different things. And after finishing a project about 2 years ago, I was just looking at the things that were going on in the industry. And what really excites me is that just the way we build and the way we produce fundamental materials is changing. You know, thanks to carbon emissions and thanks to carbon pricing, suddenly steel production and cement production is being rethought. And now when I was an engineer studying, that just wasn't something that was, considered possible. It was just, this is how it's done and it's not really going to change. So, I was looking for a real opportunity to get involved. I knew the team at Carbon Re who were starting things, and it's really exciting to work in artificial intelligence.
Yeah, no, that's really interesting. I think we've had other podcasts where people have discussed how things are changing in the cement industry after, years and years, decades and decades of things essentially not being done very differently, just sort of tweaking. And then all of a sudden there's this revolution of new technology and new approaches. So tell us a little about Carbon Re and what you're doing at Carbon Re.
So we're approaching the challenge really of carbon reduction from top down and say, okay, well, if you were aiming to reduce carbon emissions, what would you do? And the natural thing for us is to focus on cement production, steel production. Actually, those are the biggest sources of emissions. And actually, we do believe there are technologies that can improve that. And effectively, what we've done is we've combined the research of Dan Somervell at the University of Cambridge, which looked at cement production over a 7-year period and found opportunities for, real step changes of improvement in energy efficiency, together with the AI team from UCL in London, which spawned DeepMind and other kind of AI leaders. Brought those two pieces together, and actually what we found, we can use that AI technology and the algorithms, the machine learning, to drive the improvement that Dan Somervell found from his research at University of Cambridge. Combining those two, effectively what we've been able to do is a bit like my interest as an engineer in cement and steel, is bring in talent in AI and machine learning and take them from Google and Facebook and OpenAI and actually show them the opportunity in cement production and what they can do. And that excites a lot of people.
Okay. And how is this technology then deployed?
So sometimes I feel we're cheating a little bit because we're building on the hard work of other people. So if we think about industrial IoT, Internet of Things, over the last 10 years, other people have been working to put in place the data capture, the systems, the cloud historians, such that cement producers have got such rich data on what's going on in the cement plant. The challenge for them is actually how do you exploit all that data? Just the complexity of dealing with it and making decisions based on it is something that's challenging, and you'd need rooms and offices full of process engineers to really get value out of it. What we're able to do is, by using machine learning algorithms, we can take that data from the cloud historian and relatively quickly and straightforward, without any capital investment or new systems, new sensors, new data, actually find out and understand specifically what's going on in that individual cement plant and provide recommendations back to the control room operator such that they can actually optimize the day-to-day production of the plant.
So this is a way that you're combining, if you like, the expertise that the operator and the plant already has with AI, and you're sort of putting these two things together to get the best out of the system. Is that right?
Completely. I mean, some people call it something like a co-pilot. If you think about software development where AI is providing a programmer guidance on actually what the code should look like as they start to write it. Similarly, the AI is forecasting ahead, looking at free lime, degree of carbonation, thinking about clinker quality in advance, and actually able then to make adjustments to the control settings to drive that energy efficiency.
And what stage are you at in deploying the technology in cement plants?
So it's still, in one way, we're actually relatively advanced. So we've got connections, and we've run projects in India, Vietnam, in Europe, South America. So there's been a real global nature to our work. On the other hand, I think I'd still say we're still at the early stages of the machine learning algorithms. So we've got algorithms that are delivering cost savings today to cement plants. So we're there, we're established, the platform's available, the software works. What we can achieve and what we can do with machine learning, we're really at the foothills of where it can go. And just looking at the journey of other industries of where they've gone in terms of their sophistication of machine learning, we are still at the very early stages from an AI technology point of view.
So this is from the standpoint of how well the AI understands the cement industry. Is it kind of, can I characterize it like that, or is that not quite right?
Yes, I think that's actually building those out. As we evolve our algorithms from the first areas as such, whether it's free lime, whether it's degree of carbonation, whether it's the clinker quality forecasts, actually those will then allow us to move to the next stage, actually of understanding the biomass in more detail, and then better understanding the relationships with biomass and how that's affecting the temperature in the kiln, and then moving on to actually how we're working with expert optimizers at the moment. So we're just working at the moment we just completed our first project with a plant that's using an expert optimizer, and so there's the solution that we're evolving is getting really interesting, but it is something that's there and it works today.
So as I mentioned earlier, you've just published a white paper titled 3 Technologies to Reduce Climate Change. Why have you written this paper? What's the aim of writing the paper?
We see the opportunity in cement production, and I think we want to get more and more people excited. It's not saying cement production is a bad thing. It's actually, there's a massive opportunity in cement production, and everyone should get excited about how by working in cement production we can make a change to the carbon emissions. So I think everybody should be talking about it. So we feel that we should play our role in trying to make this headline news. People talk about deforestation, we talk about aviation, we talk about road transportation. Not enough people are talking about cement production. The other thing we wanted to add to the kind of focus on in this discussion is the change of date from 2050 to 2030. So there's a lot of talk about roadmaps for net zero in 2050. And our belief, which is really supported by the Nature article that we refer to in the white paper, is that actually we should be talking about 2030 more than we talk about 2050. If we think that we're doing this to limit climate change, and actually one of the ways we look at climate change is global temperature rises, the Nature article makes it very clear that actually it doesn't matter whether we hit net zero in 2050 or not. The temperature rises are driven by what we do in the next 7 years to 2030. What's our roadmap? What's our journey? And so what we wanted to do is say, okay, we're out talking to cement plants about AI. Actually, we're just part of the solution. What are the other technologies out there that also we should be talking about? And from the white paper, we actually very much similar to your introduction, actually is the technologies that we know about. It's energy efficiency. For us, that's through AI. It's the substitute cementitious materials, including LC3 as a kind of a solution, and then alternative fuels, biomass and waste-derived fuels.
Yeah, so I very much agree with your point on 2030, although perhaps for slightly different reasons. I think you're coming at it there from a scientific standpoint. I come at it more from a management standpoint. And I think if we're setting goals for 2050 and you say, well, the average CEO lasts 6 years, that's several CEOs away, and it perhaps doesn't have the same impact, if it's not something you have to deliver yourself. So I think the 2030 goals are very important because they're something that the cement industry needs to work on now because of the time delay in achieving the savings. I think the 2030 goals are much more important in driving decisions and behavior today than the 2050 goals are. So I come at it from a slightly different perspective, but the same conclusion, that the 2030 goals are very important. And I think this is a key assumption in the paper, isn't it? Because you look at CCUS and really say, well, that's not going to have very much impact in the next few years. That's something that's for after 2030.
That's right. I think one of the comments we've had back on the white paper is actually, CCUS is important. And we're not saying it's not important. It is. People need to be working on it. It is going to need to be part of our solution. Equally, though, I would say that a lot of the discussion around cement production does defer to or fall back on the idea that CCUS will be there in 2040. And there are a number of assumptions there. Firstly, the technology is still uncertain. Equally, the economic model by which we're going to fund the CCUS isn't in place yet. We're talking about the carbon tax in place for Europe, but the regulation's still evolving. It's still we're still expecting the final text from, say, the carbon border adjustment mechanism, which will really help provide the economic justification for spending the money on CCUS. And there's still massive challenges in terms of storage, and the costs and how we'll store that carbon. So it's brilliant people are working on CCUS, and that's fantastic. In addition, we really need to see how we can maximize those carbon reductions from these technologies.
So do you want to talk a little bit about the three recommendations that you make? Then the first one is about using additional supplementary cementitious materials, particularly LC3.
Yes. So, if we look at the global charts presented at CEMTEC, the conference towards the end of last year, this was Jim O'Brien evaluating the performance of all the listed cement producers, you could clearly see that Dalmia and Sri in India were far in the leadership of the other producers. And that's driven for me by their use of substitute cementitious materials. Now, I understand completely there are economic barriers to using some of these, the cost of shipping, the availability of SEMs. What we want to do is highlight, actually, we believe, from our review of actually how much is available from a top-down view of SEMs in the world, there's more we can do to maximize the use of those.
Sorry, you mentioned LC3 specifically. And of course, one of the advantages with LC3 is that clay is very well distributed around the world. And unlike blast furnace slag or fly ash, it's not looking at a reduction in supply as a result of technological change. So LC3, I think it's a very interesting technology, even though it builds on practices in terms of using calcined clays and limestone that have been around for decades. I think, the combination of the two, limestone and the calcined clay, provides a very interesting opportunity.
Definitely. I mean, so LC3 for us is really interesting because of that availability of raw material. One of the things when we were doing the research, we did understand is actually it does need more investment in plants in terms of the different line for the calcination of the clay, in terms of mixing, in terms of controls. So there are challenges, and equally the use, and acceptance of the product in the market. And how much better is it than Portland cement if you're producing your Portland cement with alternative fuels and optimizing your clinker factor? Maybe the step change to LC3 is lower. Nevertheless, with everything, we think it's part of the mix and part of the things that will help us decarbonize.
Yeah, absolutely. And then the second recommendation is around the use of biomass. So using biomass and alternative fuels, but biomass in particular. Of course, biomass is, if you like, rated as a zero carbon fuel. But there's some controversy about that, which you mentioned in the paper.
Yes, it's a real challenge. I mean, if you look at deforestation, how much does biomass lead to deforestation? I'm based in the UK, live in the UK. We see the importation of biomass from the US to the UK treated as a zero carbon fuel, and that just feels that's not quite right. That's not good carbon accounting for what's going on there. So the danger here is that we dismiss all biomass because actually sometimes it isn't good. That doesn't mean that biomass should be rejected completely, and so we do think biomass is part of the solution. Equally, as you say, other waste-derived fuels. And it's amazing to see the percentage of alternative fuels being used in Germany just because of the German rigor at separating their waste into usable materials. And if we were to do that across Europe, across the world, actually drive governments to do better separation of waste, that would really, really help the cement industry move to waste-derived fuels.
Yes, I mean, as you say, it's a long journey, and Germany's done extremely well in using alternative fuels. If you look at the rate of the use of waste-derived fuels in China and in India, then it's still very, very low. And of course, that's exactly as you say, related to the separation integration of the waste and the waste management regulations. And then just moving on to your third recommendation is on energy efficiency, and specifically using AI for energy efficiency. It seems to me that, one of the things that, and obviously it's something that you're doing at Carbon Re, but one of the big advantages for cement producers of using AI is that there's no real capital expenditure. How long does it take for cement companies to deploy AI if they were to ask Carbon Re to help them with that?
So that is the reason why for us to find, or from the analysis, the finding came out that artificial intelligence can have such an impact by 2030 is exactly that reason, that it is fast to deploy and scale. And so if you've already got a cloud historian, then all it takes is providing a data connection from our models in the cloud through to the data of your current platform, and then the time to build those models for your plant. And so at the moment, we're talking a number of months, and our pipeline is to get that down to a number of weeks. So I think the starting point would, with the conversation with the client, is to talk about the timeline, is that availability of data, and just to make sure that it's in a format we can access and start using. But once we've got the data flow up and running, actually things can be relatively quick. And it's that scalability that makes AI, really interesting.
Absolutely. David, are there other topics that we should cover before we wind up?
I think that one of the things, if I think about it if I was a cement producer looking at these technologies, the thing for me that makes it really interesting is the competitive advantage you can get by being the best at these technologies now. So yes, carbon capture and storage is going to be part of the solution that's needed in time. If we can select technologies now and invest and become leaders in technologies now as a cement producer that minimize our need for carbon capture and storage, actually, for me, that would give you a significant competitive advantage over the next 10, 20, 30 years. So the question for me is, what portfolio of technologies actually would lead to that selective advantage? And for me, as you say, kind of optimizing the clinker factor, being the best at sourcing the waste, and then using AI in an intelligent way for energy efficiency, it will be those three technologies that could get you there.
Yeah, absolutely. And I think one of the things that's very striking about the recommendations of your paper is that the proposed action will not only reduce carbon footprint, it'll also reduce costs. So exactly to your point of gaining competitive advantage. And of course, this is very much the theme of the conference that you came to out in Dubai last year, where we were talking about the potential to reduce carbon footprint and reduce cost at the same time. And a theme, no doubt, that we will come back to in the conference this year. So for all of our listeners, make sure that you have in your diaries October the 24th, 25th in Dubai, when we'll have the next WCA annual conference. So David, thank you very much for your thoughts today. It's a very interesting white paper. I recommend everybody in the industry should be reading it. So how can they find this white paper? Is it on your website?
Yes, so it's available on our website, and we've got a link. The front page of the ICR issue in February has a QR code that links through to it as well, so carbonre.com.
Excellent. carbonre.com. And we'll also put a link in the podcast notes so listeners can click on that directly. So David, great to talk to you today. Thank you very much.
Thanks, Ian.
All right. Bye-bye.
Bye-bye.